Good morning, my YouTube viewers. Crystal here. I wanted to make you another video, and what I decided to make a video on today was the Boston house prices, and I wanted to make a video to show how artificial science can be used to analyze the Boston house prices. So what I've done is I wrote my program on Google Colab, which is a free online Jupyter notebook, and then I saved it to GitHub. So I'm on the GitHub account right now. I'm going to be writing a blog post on this, and when I write the blog post on it, then I will give you the link to my GitHub account. So if you want to see the code, you need to read the blog post. So I've titled my program Boston Housing Analysis, and I'll give you a little bit of information about the data set that I'm using. This data set actually comes with sklearn data set, but I decided to go ahead and find the data set on the internet, and the reason why is because on the sklearn data set you can just load it up, but I tried loading it up and I didn't like the way it looked. It wasn't really what I'm accustomed to seeing. So as a result of that, I just went ahead and found the data set on someone else's GitHub account, and I'm using that data set on someone else's GitHub account. Because basically, if you go to sklearn, you can load up the Boston data set, but what it does is it makes X and Y automatically, but I wanted to do the pre-processing. I wanted to find out what the Boston data set looked like pre-processed. And the only way that I could do that was to go find the Boston data set on someone's GitHub account and use that, which is what I've done. So to give you a little bit of information about the Boston data set, the Boston house price data of Harrison D. and Rubenfeld D.L., hedonic prices and the demand for clean air, J. Environ, Economics and Management, Volume 5, 81-102, 1978, used in Belsley, Q. and Welch, Regression Diagnostics by Wiley, 1980, NB. Various transformations are used in the table on pages 244 to 261 of the letter. So that's some information about Boston data sets, and I do recall the name Wiley from when I was working on my master's degree. I recall reading one of the books that he wrote. So the Boston house price data has been used in many machine learning papers that address regression problems. So what we're going to do in this video is we're going to analyze the Boston data set. So since we wrote our program in Python on Google Colab, the libraries are already installed. So the only thing that we needed to do is we just needed to install the libraries that we were going to start out with, which was Pandas, NumPy, Seaborn, and Matplotlib. Pandas is a library that works on data frames. NumPy is a library that works with mathematics. Seaborn is a library that works with graphics. And Matplotlib is another library that works with graphics. Pandas is written on top of NumPy, and Seaborn is written on top of Matplotlib. And now what we're going to do is we're going to read the file, but to read the file, I gave you some information about all of the columns. One thing that I would like to bring to your attention is this column over here that says B. It says that's like the proportion of blacks in town. Now this data set was written 40 years ago, or more. And because this data set was written 40 years ago or more, at that time, they didn't feel the need for diversity the way they do now. I'm really surprised that some of these social justice warriors haven't gotten hold of this data set and demand that that column be removed. That column be removed. But so far, nobody has demanded that that column be removed. In addition to the percentage of black people, they also had a column for lower status. So they also wanted the lower status is people who were like poor, and so they had a column for blacks and they had a column for lower status. And I'm amazed. The Black Lives Matter hasn't got a hold of this data set and demanded that that column be removed. But so far, nobody's removed the column. So we're going to look at some info on the Boston data set. You see it's got a total of 14 columns and 506 entries. Most of the columns are floats. You've got a few that are integers, and they're all numeric. So that's good. That's good that all of the columns that are numeric because numbers are easier to work with. If they had any categorical columns or object columns, then you would have to convert them. You would have to encode them and convert them to numeric columns before you could put it on a model, except for CatBoost. You don't have to do that with CatBoost, but I don't use CatBoost that much. What we've done is we've described this data set. So when you describe the data set, then what you do is you get some statistics. So you get the mean, the standard, the min, the 25%, 50%, 75%, and max. But one thing that they don't give you is they don't give you the most frequently used values and the least frequently used values. But I will be covering that in the code review because that's what we're doing. We're doing a code review. So the next thing we're going to do is we're going to check for null values. In this instance, there are not any null values, and since there's not, and which is good because that means you don't have anything to impute. And now what we're going to do is we're going to do disk plot of MEDV, that's your median value, so you can see what the median values are. So the most common values are just before 20, and then you've got some values that are 50, and then you've got some other values that are really low. So now what we're doing is we're doing a scatter plot of how many rooms are in the house based upon the value. So you can see a scatter plot of that. And since the highest value is 50, you can see how it stops at 50. The next thing we're going to do is we're going to do a scatter plot of the crime rate. So you can calculate the crime rate with the value of the house. So in theory, the lower the crime rate, the higher the value of the house. And we do have a lot of houses up there with 50. So the value of the house is like the MEDV times 1,000. So if it says 50, then that means it's 50,000. So now we're doing a scatter plot of the age of the house, and how it corresponds to the value of the house. So you can see a scatter plot of that. You're seeing a scatter plot of the lower economic status of the house in accordance with the value of the house. And this is a very contentious issue. I can't believe it because you've got Black Lives Matter and the all of these other groups, and then we've got this big push for diversity. So I was really surprised when I saw this in a data set that I couldn't believe it. I think at some point, maybe to keep the data set for historical purposes, to say, well, this is, even in the housing community, but to keep the data set for historical purposes. But I do think at some point they're going to ask them to remove this column. So this is it. So this is how this is like how the Black people in the community and how it relates to the cost of the house. A scatter plot about taxes, about the tax on the house and the value of the house. A scatter plot of the parent pupil teacher ratio and the value of the house. A scatter plot of distance from work and the value of the house. So now what we're going to do is we're going to analyze the different columns. So you've got the crime rate. So the lower the value of the house, the higher the crime rate. And the highest incidence of crime rate is 14.3337, and the lowest incidence is 0.03578. Because what you have to do is you have to do a value counts, and then what you do is you take the index and you put 0 index is supposed to be the highest incidence of a value, and -1 is the last row, and that's going to be your lowest incidence of a value. And I looked that up. I got the code to look it up, and I looked that up, and they say that that's the way they do it. So I didn't really have time to go through all 506 examples to see if it was true or not. So we just hope for the best. Next thing we do is we check your zone. And so the lower price houses, you have more houses in the lower prices. The highest incidence of the zone is 0, and the lowest incidence of the zone is 18. And you can see that the highest incidence is definitely going to be 0. And if you want to go back to the crime frequency, it says your highest incidence is 14 and your lowest incidence is going to be 0. So these are violin plots, by the way. And now what we're going to do is we're going to look at the Charles River. You're going to see if the houses are on the Charles River. So you can see number 1 is it's by the Charles River, and number 0 is it's not by the Charles River. So there's not very many houses by the Charles River. And now we're going to check the industrial complex. So you can see how many houses are close to the industrial complex. So the highest value is going to be 18.1, and the lowest value is going to be 4. The next thing we're going to check is nitric oxide, because this paper that was written was environmental paper, so it was to do with nitric oxide. And so there's a violin plot of the nitric oxide, and the highest value is 0.53, and the lowest value is 0.389. So, and then what we want to do now is we want to look at rooms per dwelling. So here's the violin plot, and you can see that around 6 is the most number of rooms. And so your highest value is going to be 6.405 and your lowest value is going to be 6.625. And now what they're going to do is they're going to check the age of the units built prior to 1940. So you can see we've got a violin plot of that. You can see you have a lot of houses that are between 80 and 100 years old. So the highest value is going to be 100 years and the lowest value is going to be 40. So that was very interesting. So now what they want to check is they want to say the distance to the employment center. So you've got a violin plot that's telling you that number 2 is around the most values. And it says right here, the highest value is 3.4952 and the lowest value is 1.8125. The next thing we're going to do is we're going to check radial highways, and this is an integer. So I went ahead and checked the highest and the lowest value. So the highest value was 24 and the lowest value is 7. And you can see that that's pretty much what the chart corresponds to. Now we're going to check the tax rate. So we've got a violin chart. So the highest value is going to be 666. That's very ominous. And the lowest value is going to be 285. Now what we're going to do is we're going to check the pupil-teacher ratio. And you've got another violin chart. The highest value is going to be 20.2. And the lowest value is going to be 14.4. And again, we get to the blacks, which again, I'm surprised. I just am amazed that Black Lives Matter hasn't got onto this website and said something. I'm amazed that the social justice warriors haven't demanded that this data set be taken down. But you notice that on the column, they just put B there because they didn't want to make an issue of it because they knew that it was a contentious issue. So you got a violin plot. So around your highest value is going to be around 400, and it says right here your highest value is 396.9 and your lowest value is 390.5. Now we're going to check the lower economic status, and that's people who have a low economic status. So that's going to be close to 10. Your highest value is going to be 14.1, and your lowest value is going to be 29.05. So now what we have done is we've analyzed all of the columns. You've gotten your minimum, your maximum, and your mean. You've gotten that from the describe statement, and then we used a calculation to get the highest value and the lowest value of each of these columns using value counts. So now what we're doing is we're defining our x and our y. So our y is train.medv, and medv is the median value, and x is train.medv, x equals 1. So you can see x, where it's still got your 506 rows, and it's got your columns, 13 columns. And you can see your y is just your median value. So what we've done here is we've normalized the data. If I had wanted to, I could have used a standard scaler with sklearn, or I could have used an sklearn normalized data, but I just wanted to do some old-fashioned programming, and so write some old-fashioned formulas out, because while it's good to know sklearn and it's good to know all of the different functions that sklearn can give you, I still think that you need to use some old-fashioned programming. So this isn't necessarily old-fashioned programming, but it is mathematics, and we need to, in order to be good at data science, you have to be good at mathematics and statistics. And this is just my humble way of trying to get a little bit closer to the machine. And at some point I'm going to have to learn statistics and better than I do already. And mathematics. I studied mathematics 40 years ago, and I'll have to try to refresh my memory. And now what we're going to do is we're going to split the X into a training and test data set. And my test size is 10%. And then after we have split X, we're going to define our model. And I decided to use MLP regressor. MLP means multi-layer perceptron, and that is sklearn's own neural network. And at some point, I'm going to have to be making my own neural networks and my own functions. That's going to be what we're going to do at some point. So I used 3,000 as the max iterations. Verbose is true, so I could see what it's doing, because it's not very nice when you're sitting there and the verbose is off and it's turning away, but you don't know if it's actually doing anything. But if you've got the verbose is true, then you know it's doing something. And we have 50 hidden layers. So you can see it's turning away, doing all of these different iterations. What I'll do here is just to speed it up a bit. I'm just speeding it up a little bit. Okay, so we had 3,000 iterations. So if I'd wanted to, I probably could have had 4,000 iterations to get the accuracy up. And I might just do that when I finish this video. See if I can improve the accuracy with 4,000 iterations, because we only had an accuracy of 85%. But I predicted on the validation set, and when I predicted on the validation set, I got an RMSE of 10, which is good. I made a data frame with the Y-val and the Y predicted, and then I decided that I wanted to graph it. So this is a graph of the Y-val against the Y pred. And then I made another graph, which is probably a little bit more of what I'm used to seeing. So we plotted the actual value was the blue line, and the predicted value was the O, and we showed it so you can see where the predictions fell short of the actual values. And so I think that graph on the bottom is a little bit more of what I'm accustomed to seeing, because this graph here, it's a bit unusual. It's just like, well, what's that? It's showing you the values, and then it's showing you where it's off. But this is a lot easier. This one right here is a lot easier for me to see, for me to understand where the mistake was made. But when I finish this video, what I'm going to do is I'm going to increase my iterations to 4,000 and see if that will increase the accuracy and decrease the error. So that concludes this presentation on this code review for the Boston house prices. If you like my video, please like, subscribe, and share. If you want to keep receiving videos that I have made, if you press the bell button on the side of the subscribe button, then you will receive a notification whenever I have made a video. So I will be making a blog post on this, and then when I make the blog post, then I will give you a link to my GitHub account so you can look at the code if you want to see the code. And thank you so much for watching my video. If you want to support me, I've got my email address to my PayPal account down below because I don't have enough subscribers, which is why I have to ask for donations. So thank you so much, and I hope you have a nice day. Hope you enjoy the rest of your day. Thank you.